Good morning, everyone. Can you hear me? All right, good. Good morning. Thank you for attending the Valuing Ecosystems session hosted by Earth Observation for Ecosystem Accounting Initiative of GEO, Conservation International, NASA, the Government of Mexico, and the gracious host country, the Government of Australia. My name is Daniel John. I'm Vice President at Conservation International, and I currently serve as the chair of the steering committee of EO4EA. Before we begin, I would like to acknowledge the Ngunnawal people, who are the traditional custodians of the land on which we're meeting, and pay respect to their elders, both past and present. As we share our own knowledge, teaching, learning, and research practices, we also pay respect to the knowledge and traditions of the Ngunnawal people. I extend this recognition to all Aboriginal and Torres Strait Islanders in attendance today. All right, so for our objective today, we have the honor of having many distinguished speakers and panelists who will walk us through the importance of valuing ecosystems and their services through natural capital accounting and a framework known as ecosystem accounting. We will discuss the system of environmental economic accounts, the set of standards that make that information systematic, repeatable, and decision-ready. We will highlight Earth observation as an enabling factor for ecosystem accounting and showcase examples of national accounts and some latest developments. Let's see if this works. So in this session, we hope to make a case that there is a need to align the way we manage our ecosystems with economic systems to ensure resilience and sustainable development, that there's a growing momentum amongst countries and in particular statistical agencies to incorporate ecosystem accounting, and that the Earth observation community will play a critical role in operationalizing these standards that are under development and scaling up existing efforts. We want to make a case that ecosystem accounting enables better decision-making and can support the SDGs, the Paris Climate Agreement, the Sendai Framework for Disaster Risk Reduction, by quantifying the role of ecosystems towards these goals. And we also want to make a case that GEO is uniquely positioned to support ecosystem accounting. So as producers and curators of Earth observation data, GEO knowledge hubs can provide the platform and expertise to generate information that is relevant and readily usable by National Statistics Office for ecosystem accounting. So just going through the agenda, we will start with Peter Harper talking about what is the system of environmental economic accounts and ecosystem accounting. And then we'll talk about the EO4EA initiative before going into the national examples from the Government of Australia and the Government of Mexico, both leaders in this field of applying the SEEA to country policy and contexts. And then we're going to take a step back and look at a global perspective, as well as some of the data issues surrounding accounting before we reserve enough time for the panel discussion at the end, which will be an open floor for questions and interactivity. So I ask you to be patient. We'll get to the end where we'll have an opportunity for clarifying questions as well as discussion. So before we get there, I often put up this slide before I put up the names, just as a sort of test, and the test is usually what economist said this, and the answer is it's not an economist, it's the president of Botswana and the president of Liberia, and that's to showcase that from a developing country perspective, where there's quite a bit of dependency on natural resources, there is great demand, and I think we're at a very, very exciting time to apply the SEEA and ecosystem accounts to country policy towards sustainable development. Now, it is my great pleasure to present Peter Harper, who will kindly open our event. Peter was previously the Deputy Australian Statistician for the ABS, the Australian Bureau of Statistics. And for many years, he was responsible for ABS's environmental economic accounting program. And for several years, he was the chair of the UN Committee of Experts on Environmental Economic Accounting, the CEEA. And in many ways, a lot of the work that we're all doing, Peter, in some not a small measure, was responsible for generating the development of this. So without further ado, I introduce to you Peter.
Thank you for those introductory remarks, Daniel, and good morning and welcome to you all. Thanks for the opportunity to say a few words on SEEA, that is the System of Environmental Economic Accounting, and ecosystem accounting in particular. So the first question I'd like to address is, why do we need environmental economic accounting? Daniel put some quotes up from presidents. I've got some quotes up there from economists, because I'm an economist, so that's the way I look at the world. You'll see there are two quotes there. I won't read those quotes, but basically what they're saying is that the traditional measures used to underpin policy, particularly gross domestic product, are deficient in the fact that they don't adequately account for the environment. In particular, that environmental degradation is not taken into account in these measures. This in turn leads to flawed policy. If we ask the question, how can we lead lives that are satisfying to us while at the same time ensuring that the environment on which we depend for our lives is not debased, which I'm sure you'll agree is an extremely important question, then we need something more than traditional measures that we have relied on in the past. The environmental domain does not exist in isolation. Human activities lead to pressures on the environment. The state of the environment has consequences for human well-being, and responses to manage the state of the environment have economic and social impacts as well as environmental ones. The economy depends on the environment, and the environment is impacted by the economy. So what we need is a way that enables the integration of socio-economic information, such as the national accounts, such as labour statistics and population statistics, with information about the environment, what I'd call biophysical information, so that these linkages between the economy and the environment can be understood. And environmental economic accounting is the way in which we can join up that information about the economy and the environment. Environmental economic accounts present environmental and economic information in a structured and systematic fashion, using standard definitions based on a sound conceptual framework. This ensures that information is presented in a consistent and coherent fashion. Environmental economic accounts encourage the development of comprehensive and consistent data, and they provide a platform for producing a wide range of reports and analyses. There are three particular strengths that arise from the use of accounting frameworks. First, the use of accounting frameworks ensures that information is comparable across time, for example, from one year to the next, and across space, for example, from one country to another, or from one river basin to another, or from one biome to another. Second, the use of an accounting framework provides credibility to information through the use of standards and a sound conceptual framework. And thirdly, the use of a consistent framework ensures replicability so that the results obtained from accounts are robust and can withstand scrutiny. In short, accounts transform data into information. Environmental economic accounts enable vast amounts of economic and environmental data to be turned into information that is vital for managing our countries. Environmental economic accounts break down information silos, ensuring that data and information can be used for multiple purposes in a systematic way, thus increasing the value of data. Environmental economic accounting cannot exist unless there is environmental and other base data to draw on. This is the foundation. However, environmental data is often developed to answer one particular question or problem. It can be difficult to figure out if all the information that is needed is included, and it is not always easy to see the whole picture or to understand relationships. Environmental economic accounting helps make sense of the bigger picture and to identify pieces that are missing. Environmental indicators, which are at the top of the pyramid on the right, play an important role in the policy discussion. When these indicators are drawn from environmental economic accounts, they will be consistent and comparable, and therefore much more useful than environmental indicators that are drawn directly from basic environmental data. Of course, environmental economic accounts are only useful when they meet the needs of policymakers and other decision makers. Some of the main ways in which environmental economic accounts support policymakers include enabling analysis of the impact of economic policies on the environment and vice versa, providing a qualitative basis and a quantitative basis for policy design, identifying the socio-economic drivers, pressures, impacts and responses affecting the environment, supporting greater precision in the development of environmental regulations and resource management strategies, and providing indicators that express the relationships between the environment and the economy. So what exactly is this system of environmental economic accounting? SEEA is a multi-purpose system that generates a wide range of statistics, accounts and indicators with many potential analytical applications. It is a flexible system that can be adapted to a country's priorities and policy needs, while at the same time providing a common framework, concepts, terms and definitions. Where relevant, SEEA uses concepts, definitions and classifications consistent with the system of national accounts in order to facilitate the integration of economic and environmental data. SEEA has three core components. The SEEA central framework starts from the perspective of the economy and its economic units, and it incorporates relevant environmental information concerning identifiable environmental assets such as mineral, forestry and water resources and their relationship with the economy, conceptualises natural inputs, products and wastes. The SEEA central framework was adopted as an international statistical standard in 2012, and it was the first international statistical standard in the environmental field. It culminated 20 years of work going back to the 1992 Rio Earth Summit in developing environmental accounts based on the system of national accounts. The SEEA experimental ecosystem accounting, on the other hand, accounts for the environmental system as a whole, considering interaction between individual assets in the context of spatially located ecosystems that provide ecosystem services, as well as other relevant considerations such as altitude, climate and so on. Work on ecosystem accounting is much more recent, having only commenced in about 2007. The SEEA experimental ecosystem accounting reflects a synthesis of knowledge in the measurement of ecosystems. While it represents a convergence of disciplines across ecology, economics and statistics, at the time of its development, many important measurement and conceptual challenges remained, and that is why it is labelled experimental. SEEA applications and extensions illustrates to compilers and users of SEEA how the information in the accounts can be used in decision making, policy review and formulation, analysis and research. I really want to stress the dual nature of SEEA, that is, both as the central framework and as ecosystem accounting, because occasionally people think that SEEA is only the central framework. SEEA should be viewed as having two equal and complementary parts. It is only by having both parts that SEEA can be a truly comprehensive system of environmental and economic accounting that enables linkages to be properly explored and understood, either starting from an economic or from an environmental perspective, so that we can properly answer the question about how we can lead lives that are satisfying while not degrading the environment. The SEEA supports a range of international initiatives. These include the World Bank's Wealth Accounting and Valuation of Ecosystem Services program, the Economics of Ecosystems and Biodiversity, which is a global initiative focused on making nature's values visible, the United Nations Sustainable Development Goals, the Convention on Biological Diversity, the United Nations Development Programme's Biodiversity Finance Initiative, and the United Nations Environment Programme's Partnership on the Green Economy. Looking at the SDGs in particular, SEEA provides information relevant to 40 indicators across 9 of the 17 goals. As such, SEEA represents an important evidence base to monitor progress towards the Sustainable Development Goals, particularly in regard to environmental sustainability. And ecosystem accounting is an important part of how SEEA can help inform on the SDGs. From small beginnings, there is now widespread adoption of SEEA. 80 countries are officially compiling some form of SEEA account, and a further 15 or so have plans to do so. But this just represents the official work. There are many non-government initiatives that use the SEEA framework that are occurring right across the globe. I'd now like to say a little bit more about ecosystem accounting. And I can get a slide to come up. There we go. This slide shows a high-level model of ecosystem accounting. The SEEA EEA ecosystem accounting model has 5 main components that are reflected in the diagram. Starting at the bottom, the model is based around accounting for an ecosystem asset that is represented by a spatial area. Each ecosystem asset has a range of relevant ecosystem characteristics and processes that together describe the functioning of the ecosystem by considering the ecosystem's assets, extent and condition. Each ecosystem asset generates a set or basket of ecosystem services which in turn contribute to the production of benefits. Benefits may be goods or services or products that are included in the economic boundary of the system of national accounts, and they're referred to as S&A benefits, or there may be benefits received by individuals that are not produced by economic units, such as clean air or water quality. These are referred to as non-S&A benefits. Importantly, it's both these S&A and non-S&A benefits that contribute to individual and societal well-being. Ecosystem accounting integrates the measurement of environmental assets and the value of the benefits they provide in a coherent and consistent approach across different ecosystems. Measurement refers to the knowledge available to assess and monitor the extent and condition of environmental assets. Valuation refers to the assessments of benefits that society derives from both market and non-market goods or services provided by the environment, or importantly, the costs or welfare losses from environmental degradation or depreciation. The SEEA experimental ecosystem accounting is currently being revised with the intention to reach agreement on as many aspects of ecosystem accounting as possible by 2020. The update is being guided by a research agenda which takes account of conceptual developments, data developments and recent experiences with producing ecosystem accounts. 5 working groups have been established. These groups deal with the key areas for the update, that being spatial units, ecosystem condition, ecosystem services, key ecosystem services, and valuation and accounting treatment. An important part of the update processing is engagement with other relevant disciplines, including the Earth observation community, to help advance the research agenda. And in subsequent presentations, you'll see how important Earth observations is to the development of high-quality ecosystem accounts. An important contribution to inform the update of the SEEA experimental ecosystem accounting is the European Union's funded natural capital accounting and valuation of ecosystem projects, ecosystem services project. In the 5 project partner countries, Brazil, China, Mexico, India and South Africa, pilot ecosystem accounts are being developed based on their ability to inform policy choices, leading to the mainstreaming of biodiversity and other ecosystem-related policy issues into policy development. These last 2 slides, which I'll go through quickly, show the application of ecosystem accounting in practice, just to give you a bit of a feel for some of the things I've been talking about. On this slide, the spatial pattern of several types of ecosystems in China is mapped. And on this slide, the ecological condition of rivers in South Africa is shown for 2 time periods. Having 2 time periods available can show whether environmental condition is getting better, or as in the case with the river conditions in South Africa, worse over time. So developing accounts once off is helpful, but developing accounts on an ongoing basis so that movements over time can be tracked and analysed is a critical part of the development of ecosystem accounts. So I hope you've now got a little bit more understanding about what we're talking about when we talk about the system of environmental accounts and ecosystem accounts. And thank you very much for your interest and your attention.
Great. Well, thank you, Peter, so much for that introduction. My name is Max Wright. I work at Conservation International within our science division, and I also lead the EO for EA Secretariat, or the Earth Observation for Ecosystem Accounting Initiative here in GEO. The presentation that I'll be giving for you today will start by going over the background of EO for EA and its relationship to the UN SEEA. We'll discuss briefly the role of Earth observation in developing ecosystem accounts. We'll talk a little bit about the work streams and deliverables of our initiative, and then we'll zoom into a case study in the United States economic accounts. And finally, we'll end with the potential role of GEO towards supporting these efforts and a call to action for the EO community. So the EO for EA initiative, the purpose of this initiative is to further the development and use of Earth observations for natural capital accounting, consistent with the set of standards and guidelines put forth by the UN SEEA, and in particular, the ecosystem accounts. Our mission, then, is to document, pioneer, and develop and test methods and tools that allow Earth observation technology to more effectively enable the widespread adoption of ecosystem accounting. And our membership spans national governments, international bodies, academic institutions, and non-governmental organizations from a very diverse group of stakeholders. The links to the SEEA, one of the things that's been a recent change within the EO for EA initiative is better aligning ourselves with the UN SEEA so that the work that we do can contribute directly to the application of ecosystem accounts. As Peter described in his presentation, ecosystem accounts rely on spatial data to systematically assess the health and status of ecosystems and the benefits and flows of those ecosystems to both people and the economy. EO for EA, therefore, plays an important role as both technical advisors and reviewers of the UN SEEA ecosystem accounts, especially during this most recent revision process, being able to input our expertise and our knowledge to produce, curate, and translate EO data and products into information that's relevant for the bodies that are creating these accounts. There we go. Let's go back one. There we are. So what is the role of Earth observation? Earth observation is inherently well positioned to support ecosystem accounting because it provides reliable, consistent, spatially explicit, and standardized information over a large area, which is ideal for supporting accounts. Therefore, there's the need to develop methods and tools that allow EO data to be scalable and comparable with ecosystem accounting. We need to shift from analysis-ready data to account-ready data and products derived from Earth observations that can be readily applied by national statistics offices and within the existing accounting frameworks. And this is really the challenge of our initiative. Oh, man. I'm having some trouble with this controller today. All right, to that end, EO for EA has 4 primary work streams. The first work stream is about case studies and synthesis, bringing together the existing information and examples from around the globe and understanding how Earth observation has been used to support ecosystem accounts. The second work stream focuses on specifically the ecosystem extent and condition accounts, 2 of the accounts where Earth observation is probably most obviously relevant and necessary. The third work stream looks at the mapping, monitoring, and valuation of ecosystem services, and specifically the role that Earth observation can play in supporting that monitoring effort. And finally, the fourth work stream seeks to do capacity building and implementation. So how do we develop tools and methods that can be translated over from the Earth observation community to the accounting community? All of this is in support of our overall goal of the implementation of the SEEA EA, and it's all supported by a combination of research, partnerships, and practical application. To achieve these deliverables, the general workflow of the EO for EA initiative is to start by review and contribute to the development of methods and standards, as we're currently doing in the UN SEEA revision process. Then testing and applying EO data and algorithms specifically for the purpose of ecosystem accounting. And finally, to support platform development, develop data platforms and resources that amplify our results and facilitate ecosystem accounting at scale and allow countries to implement these accounts. Now I'm going to provide an example of some ongoing research in ecosystem accounting from the United States. The account that I'll be showcasing is the urban ecosystem accounts that are currently under development, and for two particular services, rain inception and heat mitigation. In both cases, Earth observation plays a critical role in developing models to understand these ecosystem services, and by translating these models to particular ecosystem assets, we can understand the impact of individual ecosystems in providing heat mitigation in the form of energy savings, which has a dollar value amount, and rainwater inception. And now moving from this table, which, while very useful from a statistical perspective, we can also use this information for decision making and policy. So understanding how this information is plotted on a map and which cities or metropolitan areas benefit the most from ecosystem accounting, and where there may be areas that increased investment in economic assets may lead to better outcomes. So here we have on the bottom of this image a map of incepted rainfall for US cities, and on your left and then on the right, the energy saving in dollars per household of natural ecosystems for heat mitigation. And really interestingly, we can then plot this information out, and this could be used for spatial planners within metropolitan areas or at a national level. As was mentioned in the introduction, GEO plays a critical role here, or could play a very critical role. GEO has a long history of translating EO data into actionable information to support societal benefits. And through many of our flagships and initiatives, we've already proven an ability to do so. As producers and curators of Earth observation data, GEO knowledge hubs provide the platforms and expertise to generate information that is relevant and readily usable by statistical offices for ecosystem accounting. And already under development, numerous GEO flagships and initiatives are developing data and products that are applicable for ecosystem accounting. And GEO, as a community, can synthesize this information to support the development of accounts. A lot of this information is already being developed, and what we require is this translation, co-development of data products that can be used to support ecosystem accounting within our member countries. Therefore, I propose a call to action. The current economic paradigms do not incorporate the value of nature. Therefore, we need to fundamentally change the way that we manage our ecosystems to ensure economic resilience and sustainable development. We envision, as in the EO4A initiative, a future where Earth observation systems enable environmental transparency, and the value of ecosystems is incorporated into conventional economic measures, leading to an important systems-level shift in the way we make decisions and craft our policies. Therefore, I reach out to the EO community to join us and to help support ecosystem accounting at scale and in our applications. Thank you very much.
So I'm Ali Cowood. I'm from the Department of Environment and Energy. It's slightly strange for us to be talking about environmental economic accounting because it's usually the statistical agencies that do the accounts. But we've recognised that there's a sort of end user aspect that needs to be incorporated. So I'll be talking about two things. The first is the context of environmental economic accounts in Australia, and then how Earth observations is going to help us along the way. So there's growing demand for accounts, environmental economic accounting in Australia. There is a large body of people working on accounts, and this stems from people undertaking local area studies to regional accounts and then to state and national accounts as well. Some of this is undertaken by our statistical agencies. So the Australian Bureau of Statistics, the ABS, operates under the SEEA for a wide range of environmental economic accounts, both from the central framework and the experimental ecosystem accounts. So a few up there just recently is the National Waste Account, there's the Australian Environmental Economic Accounts as well, integrated water accounts, but also energy and other accounts as well. So the growing demand is also showing that there is a wide range of uses, and that the approaches and methods that are being undertaken are also starting to vary quite widely across all of the different approaches and applications of use. There we go. So we, from a policy perspective, have agreed across our states, territories and our Commonwealth government to create a common national approach. So this is trying to gain some consistency in the approaches that we're using, trying to make sure that the accounts that are produced nationally are also usable for the states, territories and the regional and local scale accounts as well. So we've got the Environmental Economic Accounting Common National Approach Strategy and Action Plan. It's a 5-year action plan, and we're currently in year 2. From the central framework, we're focusing on working with the ABS on our national waste accounts and also our national land accounts. And we have a regional and local scale example from the experimental ecosystem accounting for terrestrial and freshwater ecosystems, with very much a focus, because we are an environment department, on our reserve system and 2 particular national parks, or a national park and a state park. And then also some work in the marine and ocean account space as well. So to undertake the strategy and action plan, all of our environment ministers approved this plan and signed up on it and released it in April of 2018. So we have our Commonwealth Australian Government Environment Minister, but then also 8 different state and territory environment ministers also signing up for this strategy. So it involves a lot of collaboration. We have representatives from all of those different jurisdictions from our government that are helping steer the implementation of the strategy and action plan. Gotta find the sweet spot for this thing. Oh. So the strategy and action plan was developed by the Department of Environment and Energy with our state and territory government and also the Australian Bureau of Statistics. So it's very much a case of a combined strategy and a combined development and implementation. So some key partners down the bottom there, so the ones not mentioned so far are CSIRO, so a scientific organisation, the Australian Bureau of Agricultural and Resource Economic and Science, so our primary industry partners, ABARES, Geoscience Australia, Earth Observation Commonwealth Department, the Murray-Darling Basin Authority, and also Parks Australia. So those 2 are involved in the policy and operational needs for their particular day-to-day activities for our ecosystem account case studies. So while we're also taking a collaborative approach to how we undertake implementing ecosystem accounts in Australia, we're also leveraging off some existing initiatives that are also being undertaken. So one of the main ones that's also signed up by essentially the same set of government agencies that are involved in the accounts process is Data Integration Partnership for Australia, and underneath that there's the Physical Environmental Analysis Network and also a locational tool called LOCI. So they're all already existing initiatives that we're trying to work into so that we can cohesively and without repeating ourselves integrate our data for our assessment and data needs. So LOCI is quite important because it's already trying to integrate society, environment and economic data, which is also the purpose of accounts. So it's trying to make sure that we have a consistent approach for how we integrate that data together with our locational information as well. So it's important for when we're looking at properties or different statistical geographies, especially those associated with our economic data that the ABS are using. And trying to package all that all up together so we have a consistent way of non-spatial people also being able to use our spatial data for their purposes. Some environmental or ecosystem ones there are TURN and the National Research Infrastructure for Australia. So they have a lot of the environmental community of researchers bringing together data as well. And Digital Earth Australia as well. So most importantly for an audience like this, that's where the main sort of interest would lie. So they've got a range of products that are appropriate and applicable to the accounts. So there's the coastal intertidal boundaries. They produce our national land cover product, but they also work with different agencies to make other data sets more applicable, which I'll talk about in a second. So as part of the strategy and action plan, and this is a big focus of our first year of undertaking our activities, we wanted to make sure that we grasp the entire array of potential end users or particular data needs, particular metrics, data sets, etc., that were relevant to the wide array of growing stakeholders in Australia. So one of the key things that we were told is that while there are particular accounts that may be developed under the central framework, which is more economically focused, they need to maintain their ecological meaningfulness so that when you apply both the central framework accounts and the ecosystem accounts, you've got that systematic approach so you can use it all together. And so that leads into the second point there, where it's most useful with particularly the land and ecosystem accounts when they're packaged and usable together. So a part of a full information system, and that's bringing together not just the account information and the interpretation there, but also the underlying data sets and analysis that needs to fill that, but also the other policy and operational needs. So this second part of the talk is more about where our geospatial and Earth observation information is coming into play. So from a central framework perspective for our national land accounts, there are two key components that we're trying to work on. And the first is trying to get our land cover data sets that we have nationally mapped across Australia and our national land use maps, those two data sets being better used together. So both the ABARES and Geoscience Australia are currently producing new land use and new land cover products for Australia, which is quite neat because it's a good opportunity to start bringing together some dual use of these particular products. And one of the key contenders from the land accounts perspective is a table that's not in the SEEA guidelines, but it's one that the ABS has found very useful. And this is a matrix of land cover by land use. So it's taking the land cover down one side and the land uses across the other. And so by enabling these two individual agencies to have these cross conversations, we're actually going to improve the way that we can facilitate that information into these particular accounts. And there's a particular national committee, the National Committee for Land Use and Information Management and Information, is particularly helping from a state and territory to a Commonwealth perspective of allowing these two data sets to improve and become more useful together. The second part, and this comes into the ecologically meaningful aspect, is that we want to make sure that the way we have the land cover as the basis for our land accounts and the ecosystem information that we're bringing in together to inform the ecosystem accounts and having that join up and be more aligned, so trying to make that ecological meaningful transition between the different types of accounts. So there's a lot of commonality in some of the attributes to be measured here, and especially a large base of that coming from Earth observations. So if we're able to understand, say, the particular attributes that would inform land cover and therefore different land cover types, and how that links through to the attributes that would inform ecosystem types, we might be able to use some of that and have a more consistent base, acknowledging that there are other data sets that would need to be brought in for the different purposes of the land and ecosystem accounts. So this is really some neat work where Geoscience Australia and CSIRO are getting together and sort of really nutting out some of these nice attribution and mapping and classification issues. Well, not issues, but innovations. The last part is actually something that CSIRO are helping us out immensely with, and this is looking at ecosystem dynamics. So we have a national map of vegetation across Australia. It's informed by a rather large network, again, of state and territory and Commonwealth people. But it's a static map, and it doesn't necessarily take into account all of the ecosystem dynamics that are relevant for ecosystem accounts, and especially when you're thinking about condition and capacity to provide services and tracking the change in flows of ecosystem services over time. So this is an example that McIntyre and Laverell have produced, and it looks at different states of a box-gum grassy woodland. So in this particular ecosystem, there's an overstory of a particular suite of trees, but then also an understory of a particular type of grasses. And it's commonly occurring where we also have a lot of our primary industries, grazing and agricultural cropping type industries as well. So it's actually looking at the different array of ecosystem services, in this case grazing cattle or dairy cattle, and how by different management practices or different intensities of uses, you're actually moving that ecosystem through different states. And that at each of these different states, you might actually start seeing a difference in capacity to provide other services or condition of that asset, and sort of trying to understand how those particular dynamics will help us in an ecosystem accounts perspective. So going through looking at the conceptual understanding of the ecosystems and trying to maintain that as we're in an economic and an accounting framework for the accounts, but then also linking that through to the potential basket of ecosystem services that we'll be getting as well. So Laverell have also looked at this for a grassland, and they've actually outlined all of the different ecosystem services that that ecosystem type could provide at each different state. So when you look at the full range of services, when you're in the different states here on the right-hand side, you can see that the dynamics, the spread of that coloured part in the centre there is changing when you see different levels of service capacity linked to those ecosystems and the dynamics that are at play there. So it's something that we're trying to increase in our accounts, our ecosystem accounts, and trying to maintain that ecological meaningfulness as we go through to linking up the services that are of interest to our end users, as well as trying to maintain a level of data and statistical quality that is needed to be used for the statistical purposes when the ABS actually compile and release accounts. Thank you.
Hello, everyone. My name is Jimena Juarez, and I'm going to present you the status and the projection of the pilot project in Mexico. It's good that I'm speaking after these wonderful speakers because now you have a very good introductory concepts of the SEEA pilots. So Mexico is one of the 5 countries which have implemented the SEEA central framework and are working on the experimental economic accounting. And so for this pilot project, we chose 4 services, and the reason for this was because these services are known for Mexico. We have information in this field. Some of these data sets we had to contribute a little bit further, but we didn't start from zero, which was the main objective of choosing these 4. I should mention as well that in Mexico, the National Statistical Office and the Mapping Agency are joined together, so that's a very good advantage for a process like this. We have the geospatial information and the economic accounting under the same roof. So it's not that the work is simplified, but it's easier to share the experts. So for the pilot, we've designed this pipeline that we've implemented for the first row, the central framework, and the second row is the part that the economic accountants are working so far. The supply of economic services is then divided into these two variables, ecosystem extension and ecosystem condition. And regarding these geospatial data sets that we already have in our hands, there is this very specialized data set called land cover and vegetation in Mexico. It's over 200 classes. So this is a simplified classification, but it's produced roughly every 4 years. So this was the main supply for the carbon service account. And the pilot project was first implemented in the state of Aguascalientes. This is where the INEGI's headquarters are. This is an example of the proposal results. The data set that I showed you, the geospatial data set, was edited a little. We did add a variable for which the land was either a natural protected area or not, and also if it was private property, public property, or something in Mexico we call ejidos. It's a shared public property. Also, as part of the experimental side of this pilot, Semarnat, the Natural Resources State Unit, has this proposed condition, geospatial information, which actually integrates a lot of variables that they manage. And the interesting part, or the experimental part of this geospatial data set, is that this integrates 2 points in time. So it talks about the behavior of the ecosystems. We've also, and Semarnat is not part of INEGI, but INEGI coordinates the production of geospatial and statistical information in the country. So it's not only INEGI's work, it's a collaboration. Also, the SEEA, the State Unit for Agriculture Information, contributed with the food services, food production services. So this is an example of the geospatial data sets that they contributed. The production of bean, and also this is a map that was put together in INEGI for the carbon density, another of the services that were included in the services choice. The mangrove information was produced at the natural resources area of INEGI, and it was under the theme of the Coastal Protection Service. And altogether, this was the result for the state of Aguascalientes. It should be mentioned that we don't believe that this is the cost of the services of Aguascalientes. Is just a way to acknowledge the ecosystems, but not a way to buy them. So it's very special for me to be here sharing these results for this pilot for you. I am not directly involved in the production of the data sets, but I was here last year in Canberra training for the capacity building for the data cube in Mexico. So it's been over a year and a half. And since these data sets take around 2 or 4 years to produce, I wanted to show you that it's we foresee a lot of progress within the SEEA pilot project using the data cube because, well, I think you've seen a bit of it in the rest of the events and sessions, but here in INEGI we've implemented it within a year and a half, and now we have the complete Landsat archive for within 90 terabytes of data of satellite imagery, which allows us to make these processes a little bit more automatically, not completely, but the timely production of the information can improve as well. Okay, so for example, this is the area of Montes Azules, or Blue Mountains in English, in 1986. So the yellow border that you are seeing is the border for the natural protected area. And this is the same area in 2017. So the cyan or blue color denotes deforestation. So we can see the effects of the public policy of the natural protected area. This is Mexico City in 1985, and we've seen the urban development across 30 years later. So you can see how the city is spreading. Regarding the mangroves or water body observations, we can also measure its behavior across time. This is a lake that supplies water to a metropolitan area of Guadalajara. It's the Lake of Chapala. So we can see how around 2003, a public policy was implemented to impede its usage, and how the extent was recovered across time. This is the city of Cancun in 1984. And we see the change throughout 3 decades. So basically, now that we have a better usage of satellite imagery and a more concise way of monitoring the change in the territory, we are more equipped to work in the pilot. This is the same city, but we're just comparing 2 years, 2000 and 2018. And well, the projection we see for this pilot is that we can follow up on the national commitments, Paris, at Aichi and Sendai, and we would like to acknowledge that we do need the contribution of private sector and other state units that are collaborating with INEGI, and also that Mexico is always committed to the adoption of statistical standards. Thank you very much.
Good morning, and thanks everyone for coming. Thanks to the organizers, Daniel and Max and Terry, for inviting me. It's a pleasure to be here. My name is Roger Sayre. I'm an ecosystems geographer at US Geological Survey headquarters in Reston, Virginia. And that means I have the great good fortune of mapping ecosystems as my day job, sometimes my day and night job. But I'm fortunate to be able to do that. And today I'm bringing to you a new resource that we've developed called World Ecosystems. There you see them at a 250-meter spatial resolution. Why am I announcing and soft launching this new World Ecosystems data set in the EO for EA workshop? Well, for two reasons. They were fundamentally derived from Earth observation data, both in situ observations as well as remotely sensed observations. And we feel that they have a great utility for ecosystem accounting applications. So happy to soft launch those here. This work is a commission from GEO, actually another initiative in GEO Ecosystems. I've been in GEO Ecosystems for several years now, leading this task to develop a standardized, robust, and practical ecosystem classification and map for terrestrial, freshwater, and marine domains. I work very closely with Esri. We have a fantastic collaboration there. The global ecosystems are essentially built from a spatial integration of three fundamental ecosystem elements: the climate regime, the landforms, and then the vegetation assemblages that occur in response to that physical environmental potential. And so we made a new map of world climate regions. These are IPCC compliant. We used IPCC criteria and formulae to develop this new climate map using global in situ Met station data, the entire archive. And so we have a number of temperature domains: polar, boreal, cool temperate, warm temperate, subtropical, and tropical. And then we also have a number of moisture domains: moist, dry, and desertic, or very dry, hyper-arid. And you put those together and you get 18 data-derived standardized climate regions. So we have a new map of world climate regions as an input to the ecosystem layer. And then we used a 250-meter global digital elevation model to develop a map of global Hammond landforms. Many more classes than these, but we aggregated the global landforms into hills, well, plains, hills, mountains, and tablelands. So we have new 250-meter world landforms as well. And then we used the European Space Agency 2015 global land cover data, and they have a number of classes that we then aggregated into these 8 classes of 6 natural or semi-natural areas: forests, shrublands, grasslands, bare areas, water and ice, and a couple of land use classes as well: settlements and croplands. And then the idea is in a GIS, we do a spatial combination of those 3 input layers. So we take the climate regions, add the landforms, add the vegetation, and we produce the world ecosystems map. And the very first thing that we want to do is then check the conservation status of each of these global ecosystems. So we overlaid the world ecosystems with the world database on protected areas, and now we know for each ecosystem its % protection in the global protected area network. And so we do have a master table of the protection of these of all ecosystems. And I've just selected just a set of records from somewhere in the middle. These all have around 5 or 6% protection in this column. And we did the gap analysis in both a conservative manner, using only strictly conserved areas, that is IUCN Management Category 1 to 4 protected areas. And then we also did the same analysis using all protected areas. So we have both a conservative and an optimistic approach. And you see, using all protected areas, the % protection goes up, sometimes dramatically. So we know that for every ecosystem. And now we know also that the UN SEEA is in need of encouraging national statistic offices to use a standardized or a reference ecosystem classification. UN SEEA is interested in a global ecosystem classification as a reference standard. And so they have been assessing a number of global ecosystem products out there. And right now, the IUCN Red List of Ecosystems community has developed a typology, a global ecosystem typology that is a classification, which is a list and description of the ecosystems. And that's really strong work, spearheaded by David Keefe in IUCN, really great work. However, their global classification is just that, it's a classification. It is not mapped, nor is it a map-based classification. So because ecosystem accounting is intrinsically spatially explicit exercise, then the IUCN ecosystems cannot be used per se. They have to be mapped first. So in that notion of analysis-ready data or accounting-ready data, the IUCN effort is not ready to plug into your accounting. So therefore, there's obviously a great interest in seeing to what extent our world ecosystems could be reconciled with, maybe crosswalked to the IUCN typology. And there is considerable testing and evaluation, crosswalking effort going on right now on that. Some folks in this room, Francois in Stats Canada and Daniel and Max at Conservation International are doing some of that, looking at the relationship between IUCN and the new world ecosystems. So there they are. We are soft launching them here today in this EO for EA side event. I'm prepared to provide the data to anyone who asks me for it, who has an interest in using it for their country or their area of interest. We have a paper in on this to a journal, and there's a favorable outcome expected there, having spoken to the editor. And so as soon as that paper gets public, then the data will go right straight into the public domain, which is a requirement for me as a public servant. We have to put our data out there in the public domain. And not only the data, but we will put any maps that we make, all the publications that we produce, the tools. We will definitely be making some online Explorer tools so you can get to know the resource and workflows. We're going to put all that stuff in the public domain. And as far as I can tell, that is exactly aligned with this notion of geo-knowledge hubs. I think so. Here's that paper that I mentioned, an assessment of the representation of ecosystems in global protected areas using new maps of world climate regions and world ecosystems. Lots of TNC authors there, you'll notice, including the very well-respected Australian conservation scientist Hugh Possingham, who actually is now the chief scientist of the Nature Conservancy. So Nature Conservancy is really interested in this work, and they are in fact using the world ecosystems now as their ecosystems framework for their organizational priority setting, their global conservation priority setting. So I'm pretty happy about that. And in conclusion, what I hope you might take away from this session is that we do have new 250-meter terrestrial ecosystem data available, derived from Earth observations, and defined as spatial integrations of the climate regime, the landforms, and the vegetation. We have already calculated the area of all these ecosystems. So in other words, the sort of global ecosystem extent is done, it's known. And not only just the extent of the ecosystem type, but we are working at the occurrences level, the patches on the landscape. And in the vernacular of ecosystem accounting, those are called ecosystem assets. So our total area of the ecosystem is actually rolled up from the area of all the ecosystem assets. So it's really nice to be able to work with these individual polygon occurrences on the landscape. Testing and evaluation is underway. The data will soon become available, and they have a clear utility for other applications in addition to ecosystem accounting, and in particular, biodiversity priority setting. Thank you very much.
Good morning. Francois Soulard, Statistics Canada. Thank you for Conservation International for inviting me to be here and to talk to you today. I'm told we're a bit short on time, so I'll try to be efficient in this talk without cutting too many corners. When Max and Danielle suggested this title for the presentation, I could have taken it a couple of ways, but I decided to kind of make it easy on me and classify and take the approach of trying to identify the different containers of data, especially Earth observation, that we use when we do the accounts. As a day job, I'm section chief. I have a team of about 10 people who produce land, water, and ecosystem accounts. So I think I'm in a good position to tell you about what kind of information we need. This shouldn't be moving by itself. So table of content, I'll be looking at why national statistical offices are interested in Earth observation, what different streams of Earth observations are available to national statistics offices, and what processes can be used to assess Earth observation data quality when generating ecosystem accounts. So a bit of a backdrop to this. Anybody working in the National Statistics Office knows that we're constantly asked to be more efficient. We always have to reduce costs and reduce response burden, and also increase the spatial granularity and timeliness, especially when it comes down to ecosystem accounting. And new to us, we also now have to integrate information from the natural sciences into the statistical system. We didn't used to do that in the past. Now we have to deal with that. In order to do that, we need new data streams, tools, and skills. StatCan has about 5,000 employees. I'll let you guess how many remote sensors we have amongst those 5,000 employees. We have a few. Also, a lot of the EO data is freely available, but are they the ones that we need? And do they have the characteristics, the quality characteristics that are useful for us? So, using Earth observation, there are many pros. A lot of the data sets that are produced by the science departments are very solid technically. They also allow us to do some national and international comparisons of some phenomena. Some of them also meet the requirements to do sub-national analysis. And also, they also give the possibility of doing environmental analysis, which is particularly important in the case of the SEEA. Now, there are a few challenges. The data sets created from Earth observations are not usually designed to serve the purposes of national statistics. Sometimes the data sets do not meet the requirement of fitness for purpose. And another challenge that national statistics offices need to learn how to integrate Earth observation and statistical activities. We got to develop the methodologies to evaluate, integrate EO and official statistics. And the second one there is real. We got to keep up with the data. Michael Varden and I wrote a paper presented at the London Group recently, and there we talk about the fact that in 2016, it was evaluated that 90% of all data points had been created in the last 2 years. 90%. So if that was the case then, we could say that today probably 95% of the data was created in the last 1 year. So how do we keep up with that volume of data as a national statistics agency? One way to do that is we got to collaborate with producers, but that's also a challenge. I'm really happy to see what's going on in Australia with the collaboration between the ABS and the Department of Environment and Energy and the territories, but I haven't seen that anywhere else. So that's for sure is a challenge in Canada. So in terms of the spectrum of data available to us to do all this work, I see it in three aspects. I see it NSOs creating their own data sets from scratch using just unprocessed satellite data. Or I see it NSOs using analysis-ready data that's been pre-processed, or NSOs using off-the-shelf data products that are available from the different science departments. And I'll give an example of each. So the UN Global Platform is an organization of different groups within the UN that is meant to allow national statistics offices to use big data, mobile phone data, scanner data, transactional data, but also Earth observation. So the UN has put at our disposition all sorts of tools for the national statistical offices to create our own data sets from unprocessed satellite data. Second example, it would be using the analysis-ready data and using existing platform. I give here the example of Open Forest, FAO, based on Collect Earth. One of my staff, who is a remote sensor, one of 3 that work in my team, told me when she saw that this was a revelation, and if she had to do the work that she used to do before, this would have saved her like 90% of her time using this kind of a tool. So it's hugely useful. But is it what we need in NSOs to create our own information? The third type is using a data product, and I'll give an example of the use of this shortly. But this is using a product, in this case, something from Agriculture Canada, that is a land use product that allows us to map events in space. So if we look at these 3 different streams and we look at the data production dimensions, if we take it from the data itself, the Earth observation or the field data or the in situ measurements, then we have the pre-processing of the data, then we have the extraction of the information, quality control, integration, and results. Stream 1, data from scratch, implies we do the whole thing. Stream 2 means that we start with the data that's been pre-processed and ready to be extracted, and Stream 3 starts with the identification of the qualities of the product that allows us to then produce our accounts. Stream 1 on the left, different data sets, and I won't go through all of them, but just to mention that the quality control is entirely different if we do that data from scratch approach than if we do a Stream 3, which is using an already existing data product, which would be based more on the 6+1 traditional dimensions of data quality that has been used in national statistics offices since pretty much 2002. 6 dimension plus 1, because we recognize that the authority is who produces the data is also an important phenomenon to measure and to understand. As opposed to the Stream 1, which would be an accuracy assessment, a peer review of the methodology and ground truthing, which is really more of the science than anything else. And in that case, the effort for me and my team would be extremely high, and on the other side would be relatively low. So this is an example of a product that we released a couple of years ago using an off-the-shelf data product of land use, and we mapped urban sprawl in all of Canada's 33 metropolitan areas. So, and we did that by integrating many different data sources, but the main source that you see represented here is a land use data product from Agriculture Canada. We see the expansion of the beautiful city of Vancouver through space from 1971 to 2011. So the product is fit for that purpose, to look at impervious surfaces, to look at the actual settlements and the road network over time. That does a good job. But we also wanted to do, from the accounting perspective, the ecosystem accounting perspective to look over time at changes in arable land and semi-natural and natural landscapes. So for the arable land, we use census of agriculture. That's an easy way to go. Natural and semi-natural, we use kind of a residual calculation procedure to look at whatever was not covered by the 2 other classes. Because the data sources, it was complicated integrating all these data sources and not creating all sorts of residuals. But if you note in these natural and semi-natural bars over time, we see a decrease. But we see that for 2011, we have an actual breakdown between forest, water, and other. We don't have that for the other years. And the reason we don't have that for the other years is that the data is not fit for that purpose. I don't have good enough an understanding of the variability, the variation, the error bars on these measurements to be able to draw lines between the different years and say with confidence that this is what really happened in terms of change over time. So one of the dimensions of data quality when using a final product, the sixth dimension, is coherence. This data set does not have the vertical coherence through time to allow me to use it for that purpose. But it's something that's required in ecosystem accounting. You just can't do it with these data sets. Also, these, I only broke it down in 3 here. I could have broken down in 10 or 12 or some land use cover classifications of 36 classes. I only have 3 because it's not coherent enough in space to allow me to break it down in more categories with sufficient confidence that what I'm reporting is actually what's on the ground, what's really happening. All that to say, nonetheless, these data sets allow us to create information that's useful for policy, and we see here that this work has led us to calculate one of the SDGs. To conclude, that's it, thank you. To conclude, this thing has a life of its own. National statistics offices and geo committees are called to increasingly work together because the work that we're doing with these data sets is not going away. There's increasing amount of emphasis and requirements on my team and teams alike to do more on this stuff. So my question to you is, should we have a common approach on creating a data quality framework? If the Earth observation community is to produce these data sets and I'm going to use it, we have to understand what quality means for both communities. And the other thing is, I'm wondering if we should focus on moving beyond ARD, which is not appropriate for what I need to do, and more moving towards more of what I call an accounting ready data. Data that would be available for me to use to start doing this accounting without specializing in doing the actual remote sensing by myself. And all 3 data streams are potentially useful for NSOs, but for sure we need to avoid duplication. And we also need to ensure fitness for purpose. So all this points to us needing to work more together in the future. Thank you.
So thanks everyone for that sort of very interesting and informative presentations. My name's Katrina Phillips. I'm from the Australian Government Department of the Environment and Energy. I'd like to acknowledge the traditional owners of the land on which we meet, the Ngunnawal and the Ngambri, and pay my respects to their elders, past, present and emerging. Before we start our panel session, are there any questions that immediately spring to mind following those presentations? I might then invite the panel members to come up to the chairs. So for those who have joined us late, we're discussing how we value our ecosystems and the role of Earth observations in environmental economic accounting, particularly on ecosystem accounts. So if we start closest to me, we have, sorry, I'm just going to go minutes. We have Roger Sayer from the US Geological Survey, Jimena Juarez from the National Institute of Statistics and Geography in Mexico, Francois Soulard from Stat Canada, Peter Harper on behalf of the UN Statistical Division, Max Wright from Conservation International, and I'm assuming Ali Cowood from the Department of the Environment and Energy here in Australia. We also have Terry Hill's he's on a roving mic over there, and Daniel John up the back from Conservation International. So when you have a question, please stick up your hand and just introduce yourself before asking the question. So I might just kick off with one that I had, and it's understanding the linkage between economic and environmental accounting and the more traditional system of national accounts. So we've seen over many decades now national statistical officers prioritising mainstream core statistics on the economy, labour market and population, particularly given the long-standing influence of those measurements, like GDP, on decision making. So one question that sprung to mind is as an environmental accounting community, what approaches do we need to take to ensure long-term investment in the metrics that we depend on to produce environmental economic accounts when that type of work is seen as more discretionary than the system of national accounts? So I might throw that question potentially to Francois first. Or Peter, if you're...
This is on? Okay. That's a very interesting question. At the end of the day, what is critically important is to demonstrate policy relevance. There has to be not just the supply of this information, but we have to be able to demonstrate a demand, and a real demand in terms of how ecosystem accounts in particular, and environmental economic accounts more generally, can inform policy. So if we can sort of galvanise a user community out there that wants these things, then they're much more likely to be part of a regular statistical work program than if they're just seen as something more sort of esoteric and academic. That doesn't mean that there's not a role for proponents of the accounts to be out there and promote them, because I think we need to show people what these things are and what potential they have. We don't want to hide our light under a bushel, so to speak, but we have to have that intersection between supply and demand, and see the demand for these things being real and visible. And quite frankly, it's got to go beyond the people in the know. It's got to go out to the broader community. The day when people are marching in the streets demanding that the government produce environmental economic accounts for decision making, that's the day the government will take it seriously and want to put significant resources into it. And another reflection on that is that one of the reasons that the national accounts and the CPI and those other key economic statistics are produced is that financial markets depend upon them. And financial markets want to hold governments to account, and they want those information produced regularly to good quality and so forth. And from a government's perspective, there's sometimes better that people don't know stuff. But if you hide these sorts of things, then you're not going to have fully effective financial markets, and that's going to have much more negative consequences for your country than any benefits you might get from hiding the information. And the reason that I say this is that in Australia, and I think in other countries, there are emerging markets for ecosystem services. So taking advantage of the development of financial markets and the need for information for those markets to operate well, I think is an important lever for getting investment into these types of statistics. So there's some observations, but it's hard work. We've got to keep selling the story, and it'll take a long time. But the national accounts didn't happen overnight. They've been work in progress for 50, 60, 70 years. Conceptually, they've probably been around since, in some ways, since the 19th century. So Rome wasn't built in a day. But yeah, that's some of the views that I've got about how we can encourage that sort of Main Street adoption and investment into accounts. Francois, do you want to add to that?
Well, I think you hit the nail on the head when you mentioned that we need to find, just to demonstrate the usefulness of the accounts. And I'm convinced of the usefulness, but we need to demonstrate it and get the people that hold the string of the purse to do the same. And that's a different target audience, because they want to hear about dollars and cents. And before we get to measuring these things in dollars and cents, we need to get the biophysical measures right, and that takes a lot of time. So I think it's an issue of getting that massive investment sufficient to do the work in biophysical measures, and then collaborate with economists that do the valuation and start talking in the same terms that the finance department, for example, would recognize.
Wanda Jimena, do you have a perspective from a mixing government point of view about how environmental accounts can be used in the longer term to complement and stand alongside a system of national accounts?
Thank you. Well, the purpose of INEGI is the production of information for policymaking and decision, basically. So someone mentioned that we should be moving from analysis-ready data onto accounting-ready data, and I will push it forward to decision-ready data. So for me, that's the goal of the economic accounting system.
Lawrence Friedel with USA, specifically NASA Earth Science. To pick up on that, while it may not be people marching in the streets, I'm thinking that this coming April is the 50th anniversary of Earth Day. It seems like an opportunity for us to attract some attention to ecosystem accounting and economic accounting, and build on the interest in the environment. And I guess I'm wondering what your organizations may be doing to attract attention to this very issue and using an event like Earth Day, or what recommendations you may have for GEO to help organize some things. It seems like a great opportunity to call attention to this. Let's build that people in the streets.
Yes, I totally agree. I don't work for any organisation at the moment, so I can just provide gratuitous advice, but it seems to me like a great opportunity. One thing I would say is that the community of people who know about environmental economic accounting and ecosystem accounting started off very small, and we've had to grow that community, including reaching out to a broader group of stakeholders than just statisticians. I think we've now got to that sort of tipping point where there is a broad enough community so that if we do go out in a more public way about these things and hammer them strongly, there's enough people out there that know about it to be able to explain it rather than everyone just going around, well, I wonder what that is, sort of thing. So, yeah, take advantage of the momentum that we've got and events like this and so forth in order to do that sort of promotion that you're talking about.
Also, they know it's the environment, they know the economy.
Yep.
Let's help them understand.
I think it's a very simple message, we need to keep getting that message out. Thanks.
So I have a couple of questions that I want to ask from my own self-interest point of view. But before I do that, any other questions? Got two up the back. So back row first, and then second back row, if that's okay.
Yeah, hi, I'm Carsten Detmann, Geoprinciple Alternative Germany. And I've been attending, last year we had side events on ecosystem account in Kyoto, and some of you gave good presentations, I remember. So could you please summarize the main progress which has been made since the last year on ecosystem account in GEO? That would be interesting, thanks.
Thank you for that. Thank you for that question. And so speaking on behalf of the EO SEEA initiative, I think the biggest shift that we've had in the last year is our better alignment with the UN SEEA. So creating a policy mandate for our initiative became a major drive over the past year, and aligning our 3-year GEO work plan with that policy mandate. So making sure that all of our activities feed up into this common goal was a major kind of shift in the way that we thought about ecosystem accounting within our initiative, and something we hope to continue to push forward as we move into our next 3 years of our GEO work plan.
And I'd say that there's a huge body of work that we're not presenting, that you're not hearing about, but I can tell you that every year there is an experts forum that the UN SEEA is hosting, and a lot of people are going and they're telling us about the ecosystem extent accounting and condition accounting that they're doing in their countries. So there's a growing body of case studies that's maturing from year to year, and so it just needs to be, get more exposure. And we can't expose everything in a forum like this, but if we could, we would like to.
Thank you. And there was another question.
Yeah, that was me. Hi, my name is Patrick. I'm from Ernst & Young. I just wanted to ask about the world climate map and if there's been much work to overlay the physical and transitional climate risks on that. So physical being temperature increase scenarios and transitional being political and social changes.
There has not been any sort of value-added analysis of the new World Climate Regions map. So we made it, and we made it as an input to develop the World Ecosystems product. But we see it as a standalone product of great value, and we are looking for people to kick the tires of that resource and put it through some of these scenarios and risk analyses that you're mentioning. But we haven't done anything with it yet. We've just taken the 50-year averages or the life of archive averages of the temperature and precip from all those met stations and put them together into what are essentially baseline climate regions. There's an awful lot of work that could be done with those going forward.
Thank you. So, good question.
Hi, Tom. I'm from the Australian Department of Environment, but formerly the Australian Bureau of Statistics. So my question kind of overlaps both of those angles. So, Roger, you can show us a national ecosystems map, and I think that just demonstrates the spatial capability that Earth observations bring on the environmental side. Peter, you're mentioning the long history of the system of national accounts and economic reporting, but I think economic data, I'm not sure if you agree with me, but there's a challenge on the economic side to be able to reach that spatial resolution that's required for ecosystem accounting, particularly the valuation of ecosystem services from an economic perspective. So I'm just wondering what your thoughts are on that.
I'll start since I have the mic, but I think you're talking about the hard bit, and I think for me the mapping of the occurrences or the ecosystem assets is really the pretty easy part, which is why I'm doing it. And then the looking at each of those assets and coming up with a condition, so the ecosystem conditioning account, that's a lot harder. But I think the hardest yet is then doing the ecosystem value accounts against those assets. And I'm not an accountant, so I'm not even involved in that part of the process, but I think it is really hard, and we are asking economists to try to be thinking in a very fine granularity and come up with ecosystem values of these ecosystem assets, which are little patches of forest on the landscape. And I don't think there's a history or a tradition of doing that, because their spatial area of interest is the nation. And so I think there is a long ways to go in that.
Valuation is a really interesting and challenging issue. Conceptually, yeah, you'd love to be able to value everything in a robust, coherent, accepted, blah, blah, blah manner. The reality is we're still a long way off that. But that said, there's been, I think, a lot of positive developments in recent times in terms of both better understanding the question around valuation and narrowing the scope of the answer. Whether there will be sufficient agreement in this revision of EEA to get everybody on board, I don't think so. But the size of the problem is diminishing. But I'd make a couple of observations which I think are relevant. Firstly, while it would be ideal to have valuation, you can do a lot of really good stuff and just finish short of valuation. So because we can't fully answer the valuation question, I don't think we should be embarrassed about what other really useful information we can still provide using an accounting framework. The second comment I would make is that the experimental framework is really helpful in terms of testing different approaches. And I think we can talk about these issues a lot from a theoretical perspective, but until we actually get out and start doing things in anger, that in itself will help us learn a lot about valuation and how we might be able to take that forward. And the last comment I would make is to use an aphorism which I'm very fond of: let's not make the perfect the enemy of the good. Valuation is critically important in the national accounts. everything is valued in dollars. But the national accounts are not perfect in terms of the valuation. Yes, if things are traded in the market, that's great. We can generally observe a market price, which is helpful. But a lot of economic activity that's recorded in the national accounts is non-market economic activity. So people use proxies. So I think we should recognise that whatever we come up with is going to be a mix of what's ideal and what works. And the issue, in my mind, is to make the measures not perfect, but good enough to inform policy and that people understand what the strengths are and what the limitations are. And I think we take that approach, we can go a long way in that, what I think is a critically important area.
I do have a little follow-up question, but I'll ask that later. I think we're going back to the...
Is it on that topic?
It is on that topic. Well, I'm interested in the role of Earth observations. From the Australian experience, and Ali, I'll let you elaborate, we're looking at sites and valuing ecosystem services at a site might be feasible, but what is the role of Earth observations in scaling that valuation up to a national scale? Environmental assets, measuring environmental assets might be doable, but has anyone made progress in scaling up from a site to a national scale, the ecosystem services using Earth observations?
I think that it depends on the purpose of the account. So it's easier to look into all of the different details when you're at a local scale, but then it's difficult to maintain that as you scale up to a national or a state account. So it becomes increasingly important to understand the data, the spatial observations that you're using, and how they can translate in scalability as well. So you might be able to gain a lot more detail at local scales, but I think it depends on the purpose slightly. A lot, and also the jurisdictional legislation too will have different needs of data for a state-based approach as opposed to what we try and achieve at a Commonwealth perspective as well, and the particular measures that they will have embedded in their legislation will change between the different jurisdictions for their purposes. So when you translate that into an account, it's important to understand all of those nuances before you decide what data set will be fit for purpose or what you can use.
From my perspective, one of the key attractions of Earth observation in the compilation of accounts is that it really helps with that issue of scalability. We saw a product that's at 250 metres resolution. We know of products that are even more detailed than that, but yet we saw a world map based on that 250 metre resolution. And while Earth observation isn't going to answer every question about scalability, particularly when it comes up to scaling up values of ecosystem services, having that as a critical input data, I think is going to be very helpful in terms of being able to address that issue of how we can produce something that's going to be relevant at a very local level and yet can roll up to something that's going to be relevant and useful at the national level. That's one of the reasons I'm really personally very excited about the potential of Earth observation for the work of environmental accounting.
So we might go to the third row and then up to
Hi, I'm still Lawrence Friedel from NASA. I have a question about terminology. The terms of economic valuation and of Earth observations are fairly different. I don't normally hear economists talking about spectroradiometers or NDVI, nor do I hear sort of researchers talking about option value or discount rates and all that. So I guess my question is, how familiar do you think the Earth observation community is with the terminology of economic valuation and all? Sort of what's been your experience connecting those different communities? And if you think that there should be more familiarity and more connection between them, what suggestions do you have for what we can do to foster that?
That's a great question, and something I think we have wrestled with and continue to wrestle with.
is trying to translate essentially this highly interdisciplinary approach. You know, environmental economic accounts are by nature very interdisciplinary, and bringing together people to make sure you're even speaking the same language can be a real challenge. I'd say from my own personal experience, attending the UN SEEA Experts Forum was an eye-opening experience for me. Coming into it from a geographer, I was thinking very much in the biophysical terms, the ecosystem service terms, but I had a very limited understanding of economics going in. And then being able to sit down with economists and have this platform for dialogue was really important. I think in the creation of these guidelines, that's created this platform and allowed us to spend time understanding the other perspectives. And so we're finally, I think it was a long time coming, but I think we are starting to get to that point where we're at least speaking the same language. Maybe I definitely do not understand all of the economic principles, and I wouldn't be able to, you know, speak very in detail about them. But what I can speak to is I can at least understand and interact with economists, interact with statisticians and national statistics offices so that we are working towards a common objective and not talking past each other.
Just one quick observation. I think it's a framing question or a framing issue. If you frame what you're trying to do in economic terms, then you'll only get economists interested. If you frame what you're trying to do in environmental or biophysical terms, you'll only get environmental scientists issued. But ultimately, the question transcends economics and environment. You know, I try to have a go at it in terms of how do we lead satisfying lives without debasing the environment. And that transcends both the economic and the environmental. And once I think you can lift it up to that, the environmental scientists can say, yeah, I see how I fit into that. The economists can say, yeah, I see how I can fit in that. And suddenly you've got a basis for a common conversation, rather than, as you say, arguing over different terminology, which I think is most unhelpful in terms of taking the work forward.
I would say involve your local national statistics office, because we do work with dollars and cents, and we do also work with biophysical measures. And you mentioned NDVI, and we may be talking about this later this week, but we produce agricultural statistics, and we use agroclimate models to forecast crop yields. So there's a bit of everything in there that you referred to.
I'd say ag is probably more statistically oriented natural resource area. Okay, thanks.
I think
It's so hard, Lawrence. I go to these expert forum meetings, and the economists come in, and whatever they're talking about is, and I resign myself to thinking, if I can only get across, explain to somebody what an ecosystem is, because I really feel they should understand that since they're doing ecosystem accounting. And I have very fixed, maybe fixated notions on what an ecosystem is. And so I want to go in there and tell them, here's, you know, the service has to come from somewhere. There's got to be a service provider unit on the ground providing those services. And if it's an ecosystem, then it's an ecosystem because of this and that. And so I go in with this trying to teach ecosystems approach, and they don't really get it, at least not right away, because I hear them later and it's like, oh, they didn't get it. But then they're looking at me going, that guy has no idea what economics is all about. And so it is really hard, but if you just keep at it and keep working with people, because the will is there that we do this together in spite of that difficulty.
So a question.
Hi. This is Craig Larley. I'm with the GEOSS Secretariat. And I was interested in a lot of the discussion where you were talking about the this demand side on the information. And it accords with my observations. This is going back nearly 20 years when I was working on a project that was looking at environmental information in support of these approaches with the economic environmental accounts, as well as the potential, the work on ecosystem accounts. The difficulty or what I'm not hearing in what was presented is perhaps concrete examples of where you see this information being used. What's either from perhaps a live example that you've worked on, perhaps at a pilot level in a country, or even a scenario in terms of how would you see decision makers? What kinds of decisions would be supported by this information? What kind of context, and what difference would that make having better information on these areas?
Ali, did you want to tackle this one?
Our accounts are still in development, so but a lot of this information is already used in particular agencies to meet their needs. So there are examples where remote sensing is used to monitor and evaluate the environment. One of the key aspects is then using that and transforming it into a different communication tool, which is the accounts as opposed to their typical reporting. So translation of information into that format, I think, is where we're trying to take this for our policy and end user perspective. I'm not sure, is there a statistical?
I can actually jump in with an example as well. So through the work that Conservation International did in Peru, we worked with the local government of San Martin to develop ecosystem accounts from start to finish, which in hindsight was rather ambitious and quite difficult. But in doing that process, we identified these key ecosystems, and we started with a pretty ambitious plan and then ended up with relatively few services that we could get all the way to valuation. But one of those ecosystems that we looked at was aguajales, which is a palm swamp. And it takes up a very small percentage of the area of San Martin, really small. I can't remember the exact percentage, but well under 5% of the land area. But that aguajales ecosystem, by hectare, is the most valuable ecosystem in San Martin. And what was happening was it was being converted quite rapidly to rice cultivation. And the rice that was being converted into, these aguajale palm swamps were being converted into, the per hectare dollar value of that rice was actually quite low and was significantly less than the aguajales swamps, which provide fruit, fiber, biodiversity corridors, water regulation, and a number of other services. So not just the ones we could even get to valuation, but a number of services that we couldn't even get to valuation. And so when we talked to the government there and we presented these results, they kind of a light bulb went on that, why were there incentives then for clearing aguajales for rice paddy cultivation, and why were some of the most unproductive rice paddies not converted back to aguajale to build back up this ecosystem asset? And so that was just one example of when the development of an ecosystem account identified a particular ecosystem of key value, at least to the local and regional economy, and then led to a change in the way that they manage their land use decisions.
If I may add to that, national accounts, Peter mentioned, they have a long history and they're used everywhere. Everybody knows that. The central framework became a standard only in 2012, and it already has really clear applications. For example, in Canada, we are able to produce what you call physical flow accounts for energy, and that allows us, because of the system, to figure out how much energy is consumed by households. So we know that in Canada, direct and indirect energy consumption by households is equivalent to 43% of all energy used in the country. So this is very important when we're talking, for example, about carbon taxes. So that's a practical example. It's not as developed for ecosystem accounts in Canada, but for sure, I showed you a map of Vancouver. We did all of the metropolitan areas, as I mentioned, and all of these data have been integrated in one of the province's municipal planning GIS systems. So they actually have a history of the growth of their own municipalities, and they're able to compare the impact of their own policies on land, on consumption, and adjust accordingly. So it's not as developed as what we have in terms of GDP, for example, but slow progress.
So Francois, actually we'll go up the back there, sorry.
My name's, excuse me, Arnold Huff. I'm with PCI Geomatics in Canada. My question is for Francois. First of all, Francois, thanks for using the term error bars in your talk. That's something that is important and often is overlooked in the field of Earth observation. My question is is with regard to the, you said that we should start, or ask the question, should we focus on moving beyond analysis-ready data towards accounting-ready data? I'm wondering whether you mean by that the job of analysis-ready data is done, or whether that's the wrong question to be asking.
Well, I'm always happy to talk about any bars, really. That's fine. Whether or not ARD is done its job, I don't know. I'm not in a position to talk. It's too big a question. But whether or not we can improve the data that are pre-processed to make them in such a way that national statistics offices can actually use them more efficiently, I think that's a given. What it means, though, exactly, I'm not sure. We will have to sit down and think about it. But for sure, having information that provides us with measures of data quality or data precision through space that go beyond just having a confusion matrix of emissions and commissions. That's not enough, because I need to have more information on the actual quality of the data in a granular way across space. So that would be an example where that needs to go. But it's certainly, it's an idea that came to me, and I think it's right, but I've not given it enough thought to have a very satisfying explanation for you.
Hi, Jason Duffy from Environment Canada. It's more of an observation, I guess, but I think it's historically the national accounting offices are more involved in the social science realm, right? Economics, demographics, stuff like that, and it's a more recent switch to natural sciences, looking at natural sciences. It seems to me that if we look at the background of how the statistics are done on demographics and economics, I mean, they're indicators, right? They're not perfect. You don't account for every dollar and every, penny, and the GDP is an estimate, and the labor statistics are estimates based on surveys and so on. They're not, it seems to me, and coming from the natural sciences and an environment where we're sometimes stifled by not having good enough information to make decisions. Does it seem that there's a higher standard being put on the requirements for accuracy of data in the natural sciences than perhaps either we should, or that we, your demographic and your statistic, your economic data have the power to, change markets and, move billions of dollars off of balance sheets in minutes, but it seems like with natural statistics, we pine over the accuracy and the error bars and the, all of this stuff before we actually get to making a decision. Coming from a conservation organization, it just seems like we're always trying to get better.
May I comment on that?
Sure.
Jason, you're absolutely right, and it is a trap that we have to be very wary of not falling into. But at the same time, the information in the natural world that we need to provide is spatially explicit. And on the other side, the main capital that national statistics offices have, and if we lose, we're doomed, is trust. Trust in our data. If people start doubting the data, then it will not, we won't have much to do. Given that the data is spatially explicit, people are able to see around them what's going on. And if we get that wrong, then it will not believe whatever aggregate, which might be true for the larger scale. So it's a fine line to walk. How far do we need to go? But as a producer of the data, I need to know if I can actually stand behind it and if it's pointing in the right direction. And right now, given where we are, I can't do that with regards to the example I gave. We can in other examples. I just gave this one, but we do produce statistics that are based on Earth observation, with which I'm confident about what's going on, and we report and analyze those, for sure. But yeah, we have to be cognizant that in the national accounts, there's a lot of estimates that are rather rough, and that we should allow ourselves at least the possibility of maybe seeing if it's necessary to go that far in the ecosystem accounts world. Thank you.
Thanks. We've got about 5 minutes left. We might go up the back first.
I'm Hans-Peter Black, IEEE. I think the development towards economically valuing ecosystem services is a very important extension of the current mainstream economic model. But I think there's also a risk associated with an economic view on the ecosystems. We had an economic view for a long time on society, and it's very easy to justify economically slavery, child work, unequal salaries, exploitation of people, and luckily, over the last 100 years, we have combined this view with ethical considerations. Slavery is outlawed in most countries. Child work is still happening and giving us a lot of services that we really appreciate, like tobacco and chocolate and all of these things. And we have a lot of inequality in salaries still. And I'm a little bit afraid that if we take a completely economic view on the environment, on ecosystems, we end up in a situation where we also create more unjust situations than necessary. At my university, we have worked with the US Fish and Wildlife Service to develop a conservation leadership program. We are training, or we are helping young people to understand the importance of being a leader in our society. And I'm very happy actually to see that many of the young people are asking ethical questions about how we look at ecosystems. They really follow the definition of sustainable development that Crick et al. In 2013 gave, where the safeguarding of the Earth's life support system is very important. And safeguarding the Earth's life support system is a little bit different from valuing ecosystem services economically, particularly in a world where companies have no social responsibility, according to Friedman. So I want to ask you, after this long introduction, whether you see any openness for combining ecosystem value with ethical considerations of ecosystems. For example, the discussion that is going on in some groups now that animals have rights, that deers, for example, have the right to be in the forest. And we cannot, just because economically it might be better for us not to have them there, we cannot just do that, just because the ecosystem services value tell us this. So maybe you can comment on, in the last few minutes, on this ethical point of view and combining it with the economic point of view.
Jimena, I noticed on one of your slides that you had provided land breakdowns by Indigenous land as well. Are those cultural values starting to work their way into Mexican accounts in terms of the cultural values also that an ecosystem delivers?
So thank you. Actually, later today we will have a side event where we discuss something related. It's called Integrity Gamma Project. It's an indicator that tries to combine these variables. But from my perspective, the issue here is that how would you measure the ethical value of something as an ecosystem? And also, sorry, I missed my point. So yeah, an issue with that is that it's very subjective to value something like that, and we try to have a very strong trust on our data. So for an NSO, I think it's kind of tricky to get into that territory, if you understand.
It's an interesting question, and we worry about it all the time. And it's one thing to say, well, when we talk about valuation, we're talking about economic and all manner of non-economic values. And so we're hoping that we do a good job with those non-economic values, so the overall value of an ecosystem is inclusive of non-economic considerations. But that's slightly different, I think, than what you're asking. And I have a son, my youngest son, is a junior in college. His head is full of all these college ideas. And he is a geographer, and his major is social justice. And I can't even convince him that the ecosystems that we've mapped are valid. And he says, yeah, well, that's just one approach. You've done it scientifically in a transparent, because I keep saying it's transparent, it's replicable, you know, it's based on data. And he says, yeah, but where are the people? Where are, you know, where's the biota in this? And their right, their intrinsic right to exist. And he wants the ecosystems to not just be delineated using scientific principles. He wants a whole other dimension that involves social justice. And I look at him and say, you're crazy. We can't do that. We can delineate them very easily, scientifically, properly, and accurately. He says, yeah, but who cares if they're not real to the people? And so he's got a point. I will concede that. But it's really a difficult thing to do. But you're right, the youth of today are thinking about that.
So we're right on 12:30. We might ask one last question and then wrap up for lunch. So sorry. Terry, can we have a mic down here, please? Sorry, fifth row back. Third row in.
Hi, I'm Mark Noord from HCP International. I have a question about bringing different worlds together. I'm involved in various initiatives on food security in Africa, working with regional governments and local companies. Of course, what's on the top of the priority list is increase in production, productivity, reducing of risk, especially related to climate change. We try to also to get the ecosystems accounting approach on the agenda. It was, well, indicated in the different workshops, etc., consultations that we had as one of the lowest priorities, maybe not surprisingly. That does not mean that people do not care. Only to get the integrated approach, maybe we have to go about it in different ways. So I was very happy with Mac's example. And we're looking at getting access to the data and through that way get a more integrated approach. So I was interested, Jimena, you mentioned SEEA. So I do not know what your interaction is with them in this respect. And Roger, with the data set on the ecosystems, is that also workable in Africa? Could they work with those data to have it as a base layer for the planning with the regional governments? Thanks.
Thank you. Chancellor, one last comment from the panel.
Okay. So INEGI is the coordinator of the production of information within Mexico, all the geospatial and statistical socio-demographic information. So our relationship with them is we are also producers of information, but we coordinate the national system of information. We tend to communicate a lot with the state units that either use or produce information. So yeah, thank you.
So I'll also follow up on that point briefly, and it's interesting, in your surveys and reaching out with communities, the valuing ecosystems becomes a relatively low priority. And that may in part be an understanding of or a lack of understanding of the interaction between ecosystems and the economy and its role for food security and providing resilience in the face of climate change and other environmental shocks. And so I know kind of in the work that CI is doing and the work that I've observed, a lot of the places that benefit most from the development and the application of these ecosystem accounts are developing countries where about a lot of the economic activities are not currently being captured in the accounting system or in the ways that we measure value. And when you're thinking about how an economy might develop, especially a developing country is moving forward, if you don't incorporate those values, you dangerously undercut the natural capital on which that development is being built. And so I think that this idea of ecosystem accounting I think maybe we do need to promote it more widely and think of it as an inclusive part of a development package, or as part of food security, for example, because none of this works really in isolation. And we really can't ensure sustainable development if we're not bringing the value of these ecosystems into the same economic decision-making process that we're using for spatial planning, for development decisions, for food security, or anything else. So that would be my personal take.
Thank you. So we are now out of time. Thanks everyone for coming along to the session. Francois, you did put a question towards the end of your presentation on should we be collaborating on a common data quality framework for using Earth observations in environmental accounting. I'm guessing the answer is it depends, but probably. So while we weren't able to have a conversation about that now, I think that'll be a really useful conversation to have. Making a new network over lunchtime, I think from an Australian government perspective, that's certainly something that we'd be interested in doing. So thanks to everyone for coming along, and special thanks to our panel members today.